We are now doing exponents as part of fundamentals of algebra. It's important to understand. Exponents are very important. So we're going to start with definition. An exponent is a number that tells the base how many times to multiply itself. So for instance, if you've got 2 to the power 2, or let's say 2 to the power 3, it means 2 times 2 times 2, right? That is what it means. There is a notation of writing an exponent. There is a base, what we call a base, x in this case is a base, and n is an exponent. So n dictates how many times x must multiply itself. So if n is equal to 2, it's going to be x to the power 2, and therefore x will be forced to multiply itself 2 times. If it's to the power 3, x will be forced to multiply itself 3 times. Simple and straightforward. Okay. Now, let us talk about laws of exponents. Law number 1. We're talking about similar bases here. You can see the base is a for both exponents that are multiplying each other, a and a. So what do? We keep the a here, and then we add the exponents. An example, you see a to the power 2 and is multiplied by with a to the power 3. So we keep the base and add the exponents, so we get a to the power 5. That's law number 1. Law number 1 states that if you're multiplying bases that are similar, you add the exponents. Law number 2 says if you divide similar bases, you take the exponent of the numerator, you subtract the exponent of the denominator, and we can see here we've done exactly that. We keep a and then we subtract the exponents. You take the one that's on top, you subtract the one that's below. We've done an example as well. Number 3, if you've got base to a power and all raised to another power, you simply multiply those powers. So a to the power m all to the power n, then it will be a to the power m times n. Oh yeah, we can say we're getting a superpower. So you can see on the example, a squared all cubed, a to the power 2 all to the power 3. You multiply 2 and 3, you get a to the power 6. And now we are talking about a product of 2 different bases, all to the same exponent. It means that we can separate this and remove the bracket and make each base to have that exponent which they were sharing. So you can see here a is to the power n and b is to the power n. Right. Lastly, number 5. We're on the last page now. Number 5, you see here we've got a over b all to the power n. You remove the brackets. Each base shall have its own power, the one that they were sharing. This is it. Okay. Here is an example. A over b all to the power 3. So you can make a to the power 3 over b to the power 3. That's it. On number 6, we have a special case, right? A special case. The reason why I'm saying so is because of the definition of the exponent. Now we see that we've got an exponent that is a negative number, and that is not allowed. Why it is not allowed is because an exponent tells the base how many times to multiply itself. Now when it tells the base to multiply itself with negatively, what does it mean? You would understand if the power was 2 or exponent was 2, that would mean the base must multiply itself 2 times. If it's x, it would be x times x. But how many times is negative 2? Because if it's to the power 0, then x to the power 0 is equal to 1. Okay, I've just jumped to number 9. So if it's a negative number, then it's unthinkable. We then have to flip over the fraction and have b over a. The exponent then becomes positive. Alright, you can see the example here. We ended up with this, right? Number 7, it's still negative exponents. We're not allowed to have negative exponents, so we flip over the fraction, it becomes positive. We also have an interesting case whereby the exponent is a fraction. It could be a proper or an improper fraction, but nevertheless you have a fraction. So this fraction, on number 8 we have base b, and the exponent is n over m. Automatically that creates a radical sign. Radical sign, it's this thing, a radical sign. So the denominator of the exponent, right, comes out here, and the numerator of the exponent comes out there. You can also write it in a different form. Let me show you. I'll write in red. You can write it as b to the power n, right? We remove this, we put this m here, and we put n. It's still the same, all the same, you get the same answer. Lastly, any number, any variable raised to the power 0 is equal to 1.